Hello and welcome to the last part of Chapter 5, Section 3. You should be at the bottom of the third page in your notes, and this is what you should see. It's the third page in your notes for this lesson. I believe the number is 148 at the bottom. And you see problem 6, modeling a function. I cheated a little bit and I put this goes on to the next page, so I put it all together here, but that's what you're looking at. So let's look at an application of this slope-intercept form in this question right here. It says that a plumber charges a $65 fee for a repair plus $35 per hour. Okay, then it says write an equation to model the total cost y. That's important for us. The total cost y of a repair that takes X hours. All right, what graph models the total cost? All right, number 22 says they're going to walk you through the question here. Now this is called defining your variable, and this is important for you to get in the habit of as we move on to some more difficult applications here. All right, you need to tell me what X represents. X is the number of hours that the plumber works. Y is the total cost. Now this particular question, they gave it to you. It might not always do that. You're going to have to sometimes figure that out. Okay, so a plumber shows up to do some work and they get paid for it. Now here's what we know. All right, there is a $65 fee for the repair. Plus, you pay them $35 an hour. So basically that means that you pay them $65 for them to show up to your house. And then they start charging you $35 an hour on top of that. So the $65 fee, that's a one-time fee. All right, that's a one-time fee that you pay. So right here, you have this, it says when X equals 0, Y equals what? So remember, X is time. Okay, so technically when time is 0, what is the cost of the bill? For them to show up, they ring your doorbell, you open the door, you owe them at that point $65 just to show up. Okay, so we say at time 0, it's $65 for them to even drive to your house. So that is the y-intercept, because the y-intercept is the value when x is 0. So the y-intercept is 65. This might make more sense for you in a moment. Now, for you, turn to the next page here, and on the screen, I'll keep this up as long as I can, and you can see how this comes together here. Now, the slope, all right, the slope is the amount of change. Remember the words rate of change. All right, that's what the slope is. And in this case, it's $35 per hour. Okay, you pay them, it increases $35 for the first hour, $35 for the second hour. So that's sloping, or it's changing 35. So try to catch how this phrase rate of change is connected to the problem. And if that makes sense to you, this will get a little bit easier for you, because as the hours increase, the change or the cost increase $35 every hour. That is the amount of change, the rate of change. That is the slope, which we really emphasized in the previous videos. Okay, so now it says write an equation to model the total cost. Well, I'm going to write it out like this for you first to try to make it make sense. I'm going to write it over here. So here's what we know, that the total cost is equal to, all right, you pay $35 times the number of hours, all right, plus you pay that $65 fee, all right? So that is the per hour, okay, and that is the one-time cost, one-time fee. All right, now remember we said that y is the total cost, right? So y is the total cost is equal to 35 times x is the number of hours plus 65. And that's what goes on in this area right here. Y equals 35x plus 65. Okay, so we have an equation now. Now, if you learned how to graph from the equation, we could graph that by using 65 and the rise over run, but they went ahead and gave us a table here. So let's work through the table just so we can see how this connects. And after this lesson, or really after the last lesson, you should be able to create a graph from either an equation or a table. All right, well, X is the number of hours. That's my top row. The total cost is the bottom row here. At 0 hours is 65. So that means after 1 hour, we add $35 to that, right? Because they said that $35 is the amount that you pay per hour. So 65 plus 35, that comes out to be $100. At 2 hours, okay, it's going to increase another $35. So that's 135. At 3 hours, that's going to increase another $35. That's 170. And at 4 hours, that's going to increase another 35, and that's going to put us at 205. And again, it's going up 35 each time. All right, so this is the table. Let's take these points and graph the equation here. And the first thing we should do is identify what the axes are. Okay, so this is the x-axis right here. So that is going to be, x is the number of hours that we worked, and the y-axis is the total cost. Okay, so at 0 hours, it was $65. So that's a little over 50. Since we're bouncing 50 there, it's going to be just above the 50 line there. At 1 hour, it was $100. All right, at 2 hours, I'm just graphing the points here now. 2 hours is 135. That's going to be, that's 100, that's 25 would be halfway there, so that's a little bit above halfway. At 3 hours is 170, so that was slightly over 150. And at 4 hours, it was 205, so that would be just above the line right there. All right, grab your straight edge right there. We're going to graph a line that starts here and has an arrow. The arrow will only go to the right because we don't have negative time. You do have to consider the context of the question. So there you have the graph represented by that equation there, and as was shown in the table there. So excellent. Let's move on down here and let's do this lesson check here, because there's something in here that we haven't really looked at, and that is what would happen if I had an equation like this. All right, y equals 5. It says, is y equal 5 a linear equation? Explain. Now, as I looked at the notes, I found this actually easier to go down here to number 28 first, and then we'll come back to 27. All right, it says find 3 points that satisfy y equals 5, because I need you to understand this. If you understand this, all right, it'll be a lot easier for you to not get confused as far as what's really happening here when they say y equals 5, or they might say x equals 5. If we know that y equals 5, that means you can pick any point where y is 5. Think of a point where y is 5, an ordered pair. How about 0, 5? Y is 5, right? Because it's x, y. What's another one? I'm going to say, how about 1, 5, right? Y is equal to 5. X is 1, but y is still 5. How about 2, 5? Okay, so there are 3 points. Do you see the pattern that y is 5 for every point? So I'm going to draw an axis right here, small one, and try to make the point of what we're talking about here. Here's the x-axis over here. Here's the y-axis. I'm going to go 1, 2, 3, 4, 5. Over here I'll go 1, 2, 3, 4, 5. All right, let's plot these 3 points. Let's plot this one first. 0, 5. 0, 1, 2, 3, 4, 5 is right there. How about 1, 5? 1, 2, 3, 4, 5 is right there. 2, 5. 1, 2, 3, 4, 5. I could keep going, couldn't I? 3, 5, 4, 5, 5, 5. All righty, look what we have now. We have a line that goes like this. We have a horizontal line that would extend forever in each direction. Right there. Okay, so now let's go back to 27 and answer this question. Does y equal 5 have a slope? Do you remember what the slope of this line is? The rise is 0, but the run is anything. So yes, it has a slope. it happens to be 0, because remember the up and down line, that's undefined. That's the one that does not have a slope. But with the graph here, you can see that that is it. Is it a linear equation? Yes, it is, because it made a line. Okay, so there are the two main ideas. The main idea, the biggest idea, is that you can take a situation like this and get to the graph and the equation. So hope that makes sense, and the good news is this is the only video for today. So get those notes down and be ready. I'm going to challenge you next time I see you.